Welcome back to our geometry extension lessons. Today we're going to be in week 5. This is our week 5 geometry extension lesson. And today we're going to be talking about surface area. So your required lesson this week is on volume of three-dimensional objects. And so the extension lesson we're going to be talking about will be surface area. So what is surface area? Well, surface area is the outside space. The easiest way that I like to describe it is if you had a gift that you're giving for a birthday or whatever, and you tried to wrap it in wrapping paper. How much wrapping paper would you need exactly? So how much is needed to cover the exact space? So if you're trying to wrap a phone in a piece of paper, how much would you need to wrap it perfectly on the front, on the back, and then can you measure that amount of paper that you used to cover up that space? So it's basically how much each of these objects around this shape, how many faces or surfaces, what is the area of each of those individually? So there are some formulas for surface area, but there's really an easy process to follow as well for some of these figures. So the first figure we have here is going to be a rectangular prism or a cube, depending on its measurements. If it's a cube, all the measurements will be the same. But let's make it something a little bit different. So let's call this a rectangular prism. If you know some of the measurements here, so let's say I've got 6 inches that's going from the back to the front of the prism here. If I've got from the side to side on the front here, we'll call that 8 inches. And then the height here. So the width, the length, and then the height here is going to be 3 inches. Not necessarily the scale, but that's okay. A couple different colors here. So basically what surface area is, and the easiest way to calculate surface area is break it down into the different pieces. So in this figure, we have this front piece, this front rectangle. I'm going to try to color that in green a little bit. Okay, so we've got that front piece there. And that front piece, the very front facing part of the cube, or the rectangular prism, I should say, we know how wide it is, how long it is right here is 8. So if I were to redraw this rectangle on its own, if I could take the front of the prism off and redraw it, take it off and redraw it, it would look like this as a two-dimensional object, and the bottom distance is 8 inches, and the height here, the side, is 3 inches. Now, in a prism like this, you actually have 2 of these spaces. I've got the one in the front of the prism, and then we're going to have the one in the back. So front and back. There are actually 2 of these. So I would have 1, and then I would multiply that value by 2 because there are 2 of them. And how do we find the area of a two-dimensional object of a rectangle? Is just length times width. So I have 8, I have 3. 8 times 3 is 24. And so I know that the area of this one front piece is 24 inches squared. Remember, the area is inches squared. And so surface area is the same thing. It is always units squared. All right, so my front and my back. So if I multiply this by 2, I get a total of 48 inches squared. So that's the front and the back there. I can get some green on that one as well. All right. Now we have the sides. We have the sides of the prism here. So I've got the side here that goes up and then kind of forward towards us. We've got this side here. Color that in blue. And again, if I were to take that side off and redraw it as a two-dimensional space, I know that its width here, or how wide it is 6 inches. And this distance right here, since it's a prism, is going to be the same on the other side. So if this is 3, then all of these are 3 inches tall. And so this figure is also 3 inches tall. Again, find the area of this one piece. 6 times 3 is 18 inches squared because it's area. And then you go back to your figure and you figure out, okay, how many of these do I have? I've got the one side here. I have a matching one over here. on the other side of the prism. Okay, so I have 2 of these. So 18 times 2 is 36 inches squared. And we've almost found all of the surfaces. We still have to find the top and the bottom. But again, since they're the same, we really only have to find one of them. Slide this up a little bit. So we've got the top here, which I know from front to back is 6 inches. And from side to side is 8 inches. So if I redraw this, I've got 6 on one side, 8 on the other. Okay. So I've got it 8 by 6. Again, 8 times 6, 48 inches squared. But I have 2 of them. I have the top and I have the bottom, which is also a 6 by 8 rectangle right on the bottom there. So multiply this by 2. You get 96 inches squared. So this is all of the pieces together, or individually, excuse me. This is all of the pieces individually, but surface area means to take them all and add them all up. So if this was a gift I was giving to somebody and I wanted to wrap it in wrapping paper perfectly without any overlap, I would have to cover this side with 24 inches and its matching side. So I need a total of 48 inches squared for the front and the back. I would need 36 inches for the 2 sides. And I would need 96 inches squared for the top and the bottom. So how much altogether? We find the sum of all of those pieces, which means you add them all together. So 48 plus 36 plus 96 all together will give me 180 inches squared. So the surface area, SA, for this figure is 180 inches squared. And that's what surface area is. It's finding all the different pieces, breaking them down, and adding them together after you find the area. So break it down into a smaller shape we know how to deal with, and we're good to go. All right. Another example here. We'll kind of go through a few examples and then show you some formulas. So another example, something like this, which is a triangular prism. So the bases are triangles. They happen to be right triangles, and they go all the way up. And so we've got some measurements. We've got 3, 4, 5, and 8 for the distance between the triangles. So how do we break that down? Well, first, let's start with the triangles. I know that I have 2 of the exact same triangles, right? I've got the triangle in the front, and it's going to match the triangle in the back. The bases of a prism are always congruent, right? So I've got these 2 triangles. I redraw the triangle. 3, 4, 5 right triangle. Just remember, the area of a triangle is 1/2 base times height. The base and the height are always perpendicular. Always perpendicular. That's something we need to remember about triangles. So I'm looking for where there's a right angle, and that tells me those 2 sides that form that right angle are my base and my height. So the area for this triangle is 1/2 3 times 4. There's my base and my height. And so the area of this triangle is 12 times 1/2 is 6. But how many of these triangles do we have? We have 2 of them. So the area altogether for both of those triangles is 12 meters squared. So we get 12 meters squared for the 2 triangles. The other pieces, which are rectangles, don't all have the same measurements. So we might have to find all of those individually. Not a big deal. We're just going to break them down piece by piece. So let's start with the back of this prism. So I've got the height of 3. And from triangle to triangle, we know is 8. That's what this measurement up front is. So this back piece here in green, that back piece back there, we've got a 3 by 8 rectangle. 3 times 8 is 24 meters squared. The base of this prism, and down here on the bottom, is a 4 by 8 rectangle. So 4 by 8. That would be 32 meters squared. So that would be the bottom here. And then the one that's easy to forget about, especially when you try to kind of do all this color coding and everything, is that front face here that's kind of slanting down in the front of the triangle. And that has a width of 5, right? From the top to the bottom here, we know is 5, like it is on this side. And then the length of that is 8, right? So this whole front piece is a 5 by 8. 5 by 8 is 40 meters squared. So what we're going to do is we're going to take 12, 32, 24, 40, add them all together to get our surface area, which is going to be 108 meters, because it is in meters, 108 meters squared. That would be the total surface area of that figure. Break it down into shapes that you know, shapes you can find that individual area for, and you're good to go. The question becomes, what happens if we run into something a little odd? And pardon my drawing, it's kind of hard to freehand a pyramid a little bit for me. I struggled a little bit with this. Well, we've got a 7 by 7 base, and a pyramid is basically, in this case, we've got the square on the bottom, and then all 4 sides are triangles. All 4 sides are triangles. So let's start with the base. That's the easiest. We've got a 7 by 7. It's a square because all the sides are the same. And so I know that I've got a square that is 7 by 7, which is 49. And in this case, since it doesn't give me units, we'll just call it U squared, units squared. Let's take a look at one of the triangles. This front one has a couple measurements. Again, they're kind of hard to see in your worksheet. You'll be able to see it a little bit better. So let me redraw it here. We've got this triangle. And I know that the base here is 7. The base of the triangle from one end to the other is 7. It gives me this middle measurement, which is super, super, super important. It tells me that this distance right here is 10. And why is that important is because that is where the 90-degree angle is formed. If you think back to the last example, why do we care about the 90-degree angle? Because of the height of the triangle. We don't know how long this distance is, but this is what we call a slant height. It's the diagonal distance. It's really the hypotenuse if I broke it down into 2 right triangles. That is not the height we use in our formula. So you need to make sure you have a perpendicular symbol when you're finding the area of the triangle. So the area is 1/2, 7, and then this is 10 is my height. So the area of this triangle is 1/2 of 70 is 35. But then again, how many triangles are there in this picture? There are 4 of them. So I would multiply this value by 4, okay, and I would get 140. I would take 140 units squared. I would add them to the 49 units squared we have in the base. And altogether, this total surface area is going to be 189 units squared. Okay, 189 units squared for this figure. Again, that's if I'm wrapping it in wrapping paper perfectly. That's how much wrapping paper I would have to use. That's kind of the idea here. The last one I'd like to take a look at is a cylinder. So a cylinder, like a pop can or some kind of can, whatever you're looking at, a cylinder has a circle as a base. And so we talked previously about how to find the area of a circle. Okay, so just a reminder, if I'm going to redraw the circle here, let's get our colors out. We got the same 2 circles. They're not drawn perfectly, but we got the same 2 circles. And so the circle has a radius of 10. I know the number 20 is in our diagram, but remember that is the diameter from one end to the other. So the radius is 10. The area of a circle is pi r squared. That's why I wanted my radius. So the area of the circle is pi times 10 squared, which is about 314 if you use 3.14 in your calculator. So it's about 314. But again, we have 2 of these. So I would multiply this by 2 so that I would get 628 in this case, again, it's meters squared for the two circles because we got one on top, one on the bottom. The tricky part about a cylinder, and it's kind of hard for me to visually show this to you during using a document camera, but how do I find the area of something like this? How do I find an area going all the way around this figure? Well, if we were able to do this, or if you make a cylinder with a piece of paper like I'm doing right here, notice that the edge of the paper, right, the edge of the cylinder is a circle, right? And how do we find the distance all the way around a circle? That's called the circumference. So this would be called 2 pi r. Circumference is 2 times pi times r, right? How far away around is the entire circle? Well, what's interesting is if you unroll a cylinder, like if you were to cut a pop can all the way down one side and unroll it, it would actually make a rectangle. Zoom out my camera here for you. So it would actually make this rectangle if you were to unroll it completely. Again, that distance from this point to this point make a circle when you do a cylinder, and the distance from those 2 points, from this point to this point, is also the width of the rectangle. Now we know the height of the rectangle is 13, but we don't know this distance here. But again, that's the circumference. So if I break it down for you and try to show you what that looks like, we said that if we unrolled it, it would make a pretty big rectangle. We know the height of that rectangle is 13. But what we actually know is that this distance from this point to this point is the circumference of the circle, which the circumference formula is 2 pi r. So the distance is actually 2 times pi times our radius, which we already used in our previous problem, which was 10. And now how do I find the area of this space? Is length times width. So this area would be 13 times 2 pi times 10. You can plug this into a calculator, get approximate answer. This area is about, and I'm using just 3.14 here in my phone calculator. It gives me about 816.4 meters squared. Lastly, take the two together. You get a surface area total of 1,444.4 meters squared. So these examples don't cover all possible shapes. There are things like spheres and other types of shapes that do have set formulas. This cylinder has a formula. Okay, the formula for any cylinder, the surface area formula is 2 pi r squared plus 2 pi r h. So this is basically what we did. This is the two circles. This is the two circles. So this is the top and the bottom. Color there. These are the two circles or bases. And this is the side of the cylinder. We did that math here. So if you knew these formulas, and we're not asking you to memorize them, if you go to Google Classroom while you're working on your assignment, I'm going to post in the resources area a link to all possible, or to a lot of different formulas that you may need while working on your extension worksheet. So if you can't break it down like we did in some of these easier figures, if you get something like a sphere that you're not sure how to use, go to Google Classroom, look for that formula sheet, and pull that up and then plug the numbers in. Okay, and so that's been our week 5 extension. Hopefully you've kind of followed along what surface area is and can answer those questions. We'll look forward to getting to our week 6 extension lesson next week. Have a good rest of your week, and we will talk to you later.